So today we're going to talk about synthesis reactions, which is, if you have your notes sheet, the third reaction type on the sheet, synthesis. And we're going to go through these kind of one by one and give you examples and then see if you can complete a reaction and balance it yourself. So we're going to start with A, free element plus free element gives us a binary compound. This one's really easy because all you have to do is know how to write the binary compound with proper subscripts based on the charges. So let's take a look at an example of A. So free element plus free element gives us a binary compound. Would be like, for example, magnesium plus oxygen yields, and then you just have to think about, all right, what's our binary compound? Well, binary means two. We only have two elements, magnesium and oxygen. It's going to be a metal and a nonmetal, so that's going to result in magnesium oxide, and because magnesium is +2 and oxide is -2, the formula is complete with no subscripts, so then we just have to balance. And since two oxygens on the left, we need to have two on the right, so I'm going to put a 2 out in front of magnesium oxide and then a 2 out in front of magnesium. So and then I can just erase all this mess and there's my answer. So that's free element plus free element gives us a binary compound. So we'll try another one and see if you can get this one on your own. Let's go with aluminum plus chlorine. So what's that going to give us? Two free elements. Go ahead and stop here and see if you can figure out your answer. Okay, so your answer should be aluminum chloride, and it's just a matter of figuring out the charges on aluminum and chloride. Aluminum's +3, chloride is -1, so we need 3 chlorides. And so it's AlCl3. Alright, so then we just have to balance, which means in this case we're going to go with least common multiple of 2 and 3 to balance chlorine. So 2 aluminum chlorides, 3 chlorines, and then my 2 aluminums are there, so I have to have 2 aluminums there. So let's go to B on the sheet. It says metal oxide plus water yields metal hydroxide. So what's that going to look like? A metal oxide would simply be, for example, let's go with CuO, so that would be copper 2 oxide. If that reacts with water, that's going to give us a metal hydroxide. So in this case, copper 2 hydroxide, which means I'm going to have 2 hydroxides, right? So a metal oxide, so any metal paired with oxygen, water we already know, H2O, is going to yield a metal hydroxide. So same metal, same charge, paired with hydroxide. So let's balance it. We can't balance it with as hydroxide because hydroxide only shows up on the right. So we're going to have to balance oxygen and hydrogen separately, although in this case it looks like it's already done for us because I have 2 oxygens on the right. Because of the subscript, I have 2 oxygens on the right, and I have 2 oxygens on the left, 2 hydrogens on the left, and because of the subscript, 2 hydrogens on the right, and 1 copper on each side. Okay, so go ahead and pause the video and see if you can figure this one out. So this one's going to give us potassium hydroxide. Pardon me, KOH is 1 to 1 because K is +1 and hydroxide is -1. We do have to balance this one though. It looks like I need to balance potassium with the 2. That gives me 2 oxygens on the right. I do have 2 oxygens on the left. It also gives me 2 hydrogens, and I have 2 hydrogens. So that one's done. Okay, let's go ahead and move on to letter C. A metal oxide plus carbon dioxide gives us a metal carbonate. All right, so a metal oxide would be like, for example, let's say Na2O. It's a metal paired with oxygen. Carbon dioxide, CO2. It's going to give us a metal carbonate. So in this case, our metal Na carbonate, of course, is CO3. And I am going to need 2 sodiums because carbonate's -2. Then I just have to balance. And again, it looks like this one's already balanced for us. All right, so let's try another one. Let's say we had Fe2O3, iron 3 oxide. If that reacts with carbon dioxide, go ahead and pause the video and see if you can figure out what that's going to make. So you should have come up with iron 3 carbonate, and again, it's iron 3 because it was iron 3 over here, which I could tell by the subscript on the oxygen. And to balance it, we're going to end up putting a, it looks like I've got 3 carbons. That would be one thing I could do first on the right, and only 1 on the left. So if I put a 3 there, that's going to give me 3 times 2 is 6 oxygens here, plus another 3 there. So that gives me 9 on the left, but I also have 3 times 3 is 9 on the right, and this one is balanced. Okay, so for letter D, metal chlorides plus oxygen gives us a metal chlorate. So if we just think about what that means, what is a metal chloride? Metal chloride is just going to be a metal like, well, let's go with zinc and then chloride. And then if we're going to add that to oxygen, that's just going to be O2 because oxygen is diatomic, and it's going to give us a metal chlorate. So it's going to be zinc chlorate. So you just have to think about charges. Chlorate is ClO3 with a 1- charge, so I'm going to have 2 of them, and that's it. So let's try another one. Let's go with nickel 3 chloride and oxygen. Oh, I'm sorry, I forgot to balance my previous equation. It looks like I have 6 oxygens up there, so I do need to put a 3 in front of O2 on the left. But I did have 2 chlorines and 1 zinc on each side, so that one should be good. Okay, so on to our next problem, NiCl3 plus O2. Go ahead and pause the video and see if you can figure that one out and balance it. Okay, so that should give me nickel 3 chlorate. And again, I knew it was nickel 3 on the left because of the 3 on the chloride. So I'm going to have 3 chlorates on the right because chloride and chlorate are both -1, so they would end up having the same subscript if paired with the same +3 ion. Balancing's a little trickier on this one. Chlorine is already balanced, but oxygen I have 9 on the right and of course 2 on the left. So I would initially at least go ahead and go 4.5 to give me 9 on the left, but then I have to multiply everything by 2. So I'm going to go with 2, 9, and 2, which of course cannot be reduced. Okay, so that is it for A through D under synthesis reactions. Of course, synthesis, I didn't say this earlier, but synthesis means we're making something. So with synthesis reactions, you're always going to end up with one compound as your product because you're making something out of multiple other things. And A through D, you'll notice, correspond through A through D under decomposition, which is the opposite. Instead of making something, we're breaking something down. So all of the definitions for A through D on synthesis, you just flip them around and you have decomposition reactions. So if a binary compound breaks down, it breaks down into 2 free elements. If a metal hydroxide breaks down, it breaks down into metal oxide and water. So it's the exact opposite of what we saw up above with synthesis. And we'll do some examples of E and F a little later.